Hello and welcome back. I'm your host Nathaniel Posesorsky, and today is another video on applied advanced calculus. We're going to be looking at independence of path today. Are you ready? Let's jump in. Independence of path. The first thing you want to do in these types of questions is you want to see if it's independent / conservative. We've seen in the previous videos that in order to know that, you want to do the curl of f and see if it's equal to 0. Now, a good trick to use whenever you have x, y, and z is di p over di y if it's equal to di q over di x. And if di r over di x is equal to di p over di z, and if di q over di z is equal to di r over di y, if all three of those are true, well then it is independent and it is conservative. And then you can move on to your next step of independence of path. Why are we doing independence of path exactly? Well, we're doing it to calculate the integral of f dr, which is work. But it's important to know that the first thing we need to do in these questions is to check if it's independent. So if you understand my trick over here, this should go by really quickly. If you're doing di p and di q, well then you know that q is for dy, so you're going to do di p divided by dy. And so that's the trick. And if you keep on applying that trick everywhere, you'll be able to find if it's independent easily. Now let's go on to actually solving a problem. So first we're going to look at fxyz. It's equal to 2z plus 3yi plus 3x plus 4zj plus 2x plus 4yk. If we do di p over di y, it gives us the same thing as di q over di x, which is 3. And then we do the same thing again for di p over di z, di q over di z, and we solve all three of the conditions like we saw over here. And we see that yes, indeed, it is conservative. We're also given an initial value problem. They give us that f0, is equal to 0. We're going to use that later on at the end of the problem. But let's start by solving over here. They give us, we have this little symbol over here. It's called phi. This phi is going to be equal to the integral of p dx plus gyz. That's the first step you want to take in these independence of path problems. You want to do the integral with respect to x of p, and p goes with dx, so it only makes sense. So you're going to do the integral of p dx, which is going to give you 2zx plus 3yx, and then you're going to add gyz. That kind of acts as our constant whenever we do an integral. But we're going to write it like that. Then we're going to take our phi over here and we're going to do the derivative with respect to y. So that's going to give us 3x plus g prime yz, and we're going to place that equal to our q, which is 3x plus 4z. We see that the 3x cancels out, and we're left with g prime of yz is equal to 4z. If we do the integral with respect to y, since we're doing di phi over di y, we're left with gyz is equal to 4zy plus hz. Never forget that little constant at the end. Over here we're placing it as hz. Again, we're going to do, well, first we could plug in gyz back into the phi equation. So we get 2zx plus 3yx plus 4zy plus hz. Now again, we're going to do di phi over di z this time. And we're going to have 2x plus 4y plus h prime z is equal to r, which we had at the beginning to be 2x plus 4y. And so, h prime of z is going to be equal to 0, and h of z in that case is going to be just c, a constant. This is where our initial value comes into play, because we had f of 0, is equal to 0. So if we plug in x as 0, y as 0, z as 0, we find that our constant is also equal to 0. Finally, we are almost done. We are told that it goes from 0, to 1, 1, 1. So the work is going to be the phi from 0, to 1, 1, 1. if we plug in 1, 1, 1, minus phi from 0, 0, 0, it gives us a work equal to 10. And that's how we solve independence of path. I hope this was helpful and it helped you understand independence of path a bit better. If so, please make sure to leave a like and subscribe to the channel, and I'll see you in the next video on Applied Advanced Calculus. Thank you.